Let's discuss about redox reactions. The term redox is a shortcut for oxidation reduction. It's another type of reaction. Last time we have discussed about acid-base reactions. Acid-base reactions involve the transfer or movement of protons or the H plus ion. In redox reactions, this involves the movement of electrons. So here we're going to focus or to trace the movements of electrons. Again, it's composed of two simultaneous reactions, the oxidation, then the reduction reaction. Oxidation is the loss of electrons, reduction is the gaining of electrons. So it's quite confusing, right? Because here the gain of electrons is actually called the reduction. To help you with this, just remember this one, oil rig. This means oxidation is loss, reduction is gain. Again, this loss and gain is all about the electrons. Also, to make things simple, just associate reduction with the reduction or the decrease in oxidation number. Then for oxidation, increase in oxidation number. Now, what is an oxidation number? The oxidation number will be the hypothetical charge of an atom if all the bonds of atoms or two atoms of different elements were 100% ionic. I will emphasize this one later. Let's discuss the different rules in assigning oxidation numbers. These are some rules. First, the oxidation number of a free element is always 0. For example, we have zinc. So this one is a free element. It's not bonded to other elements. So the oxidation number of zinc will be 0. We also have oxygen. So it's composed of two atoms of oxygen, but here it's still bonded to itself. So it's not bonded to other elements. So this one is also a free element and its oxidation number should be equal to 0. Let's jump first to number 3. The oxidation number of oxygen in compounds is usually -2. So for example, in CO2, so in this case, it's not a free element anymore because it's bonded to other elements. On this case, it's bonded to carbon. Here, the oxidation number of oxygen here is -2. Next, let's go to number 6 first. The usual oxidation number of hydrogen is +1. For example, we have HCl. So here, the oxidation number here is +1. Then for the rule for number 3, 4, and then 5, for number 2, the oxidation number of monatomic ions equals the charge of the ion. For a neutral compound, the oxidation numbers must add up to 0. For polyatomic ion, the oxidation numbers must be equal to the charge of the ion. So here, the oxidation number will be equal to the charge in this one. So these are the different ions. And then here we have the charge. So this charge will be the oxidation numbers of these different ions. So I think that's understandable. Let's try to practice assigning oxidation numbers with this reaction. Here we have zinc. This zinc is not bonded to other elements. This one is a free element. So here the oxidation number is equal to 0. The same thing for this one. The oxidation number is also 0. Here we have a neutral compound. So here it's composed of copper and then sulfate. So first, let's get the charge of sulfate. So for this, we need to look into our table. This is also found in your book in Chemistry 1. It's on the last part of your book. So for sulfate, the charge here is -2. So overall, where is that? Okay, the charge of this sulfate ion must be -2. And let's go back to our oxygen here. So this oxygen is in this compound. Again, the oxidation number of oxygen is -2. So here the oxidation number is -2. That's for oxygen. So here, if the charge of oxygen is -2 and we have 4 oxygens, so overall, the charge of these oxygens on this sulfate ion would be negative. That would be -8, right? That would be 4 times -2. That's -8. Again, the overall charge of this sulfate ion must be -2. If the charge of oxygen is -8, what should be the charge of sulfur on this ion? Of course, that should be +6 because +6 plus -8 is equal to -2. So here the charge or the oxidation number would be +6. So that would be +6. That's the oxidation number of sulfur on this sulfate. So this sulfate is bonded to the copper. Again, overall, this copper sulfate is a neutral compound, meaning the overall charge should be 0. If the charge of sulfate is -2, what should be the charge of copper in this case? So the copper should be, of course, +2, right? Because +2 plus -2 is 0. So here, again, the charge, this one is the oxidation number in this case. So the oxidation number of copper here is +2. Let's go to zinc sulfate. So zinc sulfate, the same thing, is composed of zinc ion, then sulfate ion. Again, the overall charge of sulfate, as we have discussed earlier, is -2. That should be -2. Oxygen, the oxygen oxidation number should be equal to -2. So -2. If we have -2, then we have Opatka oxygen, that would be 4 times -2. Therefore, the overall charge of oxygen on this sulfate ion is -8. Again, the overall charge should be -2. So what should be the charge of sulfur in this case? This should be +6. +6 plus -8 is obviously -2. So here, the charge will be the oxidation number. So here, the oxidation number will be +6. The same thing, again, this one is a neutral compound. So here, the overall charge is 0. If the sulfate is -2, what should be the charge or the oxidation number of zinc on this case? So this should be +2, right? Then, of course, this charge would be the oxidation number in this case. So this would be +2. Okay, +2. So here we have assigned oxidation numbers on all the elements on this reaction. Let's try to erase the extra things here. Let's track the movements, the loss, and then the gain of electrons. Let's start with zinc. So from zinc, that would be, sorry, erase. From zinc to zinc. So here, from 0 to +2, there is an increase in the oxidation number. So this one is an oxidation reaction. This one has been oxidized. It's oxidation. So from 0 to +2, it becomes positive. That's because it has lost electrons. Again, a particle will become positive when it lost electrons. It will become negative if it gained electrons, because again, electrons are negative. In this case, it becomes positive because it has lost electrons. It has lost electrons. Okay, again, it has lost electrons, 2 electrons on this case. Next, let's examine other elements here. Copper, that is from +2 to 0, so it decreased, right? So this one is the reduction reaction. So here we say that copper has been reduced, that is from +2 to 0. So here its oxidation number is reduced because it has gained electrons. So it becomes less positive, meaning it gained electrons. That is from 2 to 0, it means it has gained 2 electrons. Let me write that down. Gained 2 electrons. So as you see here, then let's go first to the others pala. Sulfur, that's +6, +6, walang changes. The same sa oxygen, -2, then -2. So as you observe here, these two reactions are related to each other. So here, our zinc has lost electrons, and that 2 electrons went to our copper, right? Because our zinc lost 2 electrons, the 2 electrons was gained by the copper. So here, we can say that this zinc has been oxidized. It lost 2 electrons because copper took it. So si copper ang reason bakit na oxidize si zinc. So we say that here copper is our oxidizing agent. Oxidizing agent. It's the one that caused the oxidation of copper. On the other hand, this copper has been reduced because of the zinc. So zinc here is our reducing agent. a reducing agent. So in summary, the zinc has been oxidized. It's also the one that so it's the reducing agent. Then here our copper has been reduced, so the one that is being reduced, that one will be our oxidizing agent, so they affect each other. Let's have another example. Here we have Mg plus 2HCl forming MgCl2 plus H2. Here we have Mg. So Mg, of course, it's a free element. So here the oxidation number is 0. The same thing for this one. It's a free element. It's not bonded to other elements. So this one is, the oxidation number is also 0. Next, we have this HCl is composed of hydrogen, and we can use number 6. The oxidation number of hydrogen is positive 1. So positive 1, sorry, this should be positive 1, positive 1. So this one, wait, let me just rewrite that one. Positive 1, so positive 1. Okay, again, the overall charge of this one must be equal to 0 because HCl is a neutral compound. So if the charge of H is positive 1, what should be the charge of Cl here to make it 0? So obviously that should be negative 1, right? Because positive 1 plus negative 1 is equal to 0. Let's go to our MgCl2 here. So MgCl2 is composed of magnesium and then chlorine ions. For the charge here, just look on your guide. So I think it's over here. Magnesium, that is positive 2. So this will be the oxidation number of magnesium also. Let's put it here. That is positive 2. Again, MgCl2 is a neutral compound, meaning the overall charge of this compound must be 0. So if the charge of Mg is positive 2, what should be the charge of Cl here, considering that there are 2 chlorines on this case? So of course that should be negative 1, right? Because of course negative 1 times 2, that is negative 2, right? That is negative 2. And again for Mg, that's positive 2. So it's equal to 0. So we have assigned all the oxidation numbers in this reaction. Let's now look for the gain and then the loss of electrons. Let's look on the Mg or magnesium, that is from 0 to positive 2. This has increase in oxidation number. Increase in oxidation number is oxidation, right? So here there is a loss of electrons because from 0 it becomes positive. So we say here that Mg has been oxidized. Next we have for hydrogen. Let's focus on hydrogen. Hydrogen from positive 1 to 0. So here there is a decrease in the oxidation number. A decrease in oxidation number, that's the reduction. Reduction. So we say that hydrogen has been reduced. It has gained electrons. Now again here, Mg has been oxidized. So Mg here will be our Mg will be a reducing agent. Reducing agent. Here our hydrogen has been reduced, so here hydrogen will be our oxidizing agent. Oxidizing agent. Of course for chlorine it's still the same, right? Negative 1, then negative 1.
Hey everyone, I'm Dandy Marayag. Thank you very much for watching this lecture videos. So we have been together since the first semester. So it's been about 10 months since we first met. So we had been together for a whole school year and a lot of things had happened. Thank you very much for trying to comply all the tasks and trying to watch all these lecture videos. Of course, chemistry is not easy. It's not that hard either. Thank you for trying to cope up and to survive this subject. Thank you for making my teaching experience exciting. And thank you for all the efforts you have shown me and for this subject. I hope you learned a lot from me and from my subject. Of course, uh, it's an online class, so there are barriers that we had. And thank you for trying to understand also our case because we also had a lot of challenges while having the online class. So this will be our last lecture video and my last video. So thank you very much. I hope you graduate. So see you soon.